A modern mega cruise ship docked at dawn is so vast it distorts perspective. Rising from the harbor, its sheer vertical height practically erases the horizon. Look closely and you'll see a vertical city block stacked with thousands of balconies. Glass corridors suspended above the water ferry passengers into a self-contained world of continuous light and activity. A passenger can stand on an open deck in the middle of a lethal, unforgiving ocean and forget entirely that they are crossing it. This vessel functions as an autonomous system engineered to sustain life at sea while making its own internal machinery invisible. Traditional ocean liners were built to survive the water. They featured heavily reinforced hulls and pushed through rough weather to maintain strict transatlantic schedules. A modern cruise ship takes a different approach. The route is flexible, and the vessel itself is the destination. To understand this shift, look at how we measure ship scale using gross tonnage. Gross tonnage calculates internal enclosed volume rather than physical weight. The ship's structure fills with usable space, focusing on passenger environments like theaters, atriums, and cabins. Maximizing that internal volume allows the ship to integrate millions of components, shifting its purpose from surviving the ocean to distracting its inhabitants from it. Below the waterline, the heavy machinery goes to work. These ships rely on diesel-electric systems, where giant diesel engines generate electricity for a ship-wide grid. A single integrated loop powers the propulsion motors, while simultaneously running air conditioning, lighting, and hotel services for thousands of people. That electrical power often feeds into Azipod propulsion units. Instead of traditional static shafts and rudders, these rotating pods house electric motors outside the hull. They spin a full 360 degrees, maneuvering the ship with precision. To handle rough weather, active stabilizer fins deploy from the hull. Like underwater wings, they pivot to absorb waves, negating the vessel's natural rolling. These systems actively counteract the physical forces of the ocean, engineering an artificial stillness for everyone standing on the decks above. Sustaining that population requires an industrial-scale logistical intake. Every time the ship docks, crew members rapidly load fresh produce, massive pallets of meat, and endless supplies through side doors, stockpiling enough inventory to feed a small city. The ship also manufactures its own fresh water. Using a process called reverse osmosis, highly pressurized seawater is forced through a porous membrane, stripping away the salt particles and generating thousands of gallons of clean drinking water. All of that consumption creates a massive output. A large cruise ship processes up to 1 million liters of wastewater every single day. Advanced onboard treatment plants run continuously to purify this waste, keeping the ship hygienic and compliant with environmental laws. Running quietly alongside all this is a rigid safety infrastructure mandated by the Safety of Life at Sea Convention. Passengers are integrated into this system through mandatory muster drills, while a fleet of high-capacity lifeboats waits on the lower decks as a total survival redundancy. The ship is holding a fragile biological system. If the power generation, water processing, or waste management were to fail, the environment inside the vessel would rapidly collapse. Navigating an ocean remains inherently dangerous. Bridge officers constantly calculate complex weather routing to avoid damaging swells, while the crew trains to manage the threat of fire breaking out inside a densely packed, electrified steel structure. When human decision-making fails, the barrier between the passengers and the ocean breaks. In 2012, the Costa Concordia ran aground, leaving its brightly colored leisure decks submerged in dark coastal waters. The tragic grounding resulted in 32 deaths. It exposed weaknesses in emergency response coordination and forced global reforms in how cruise lines manage passenger safety protocols. No matter how comfortable the cabins are or how reliable the stabilizers seem, the ocean reclaims its lethality the exact moment the engineering fails. Even when functioning perfectly, these massive vessels generate friction where they dock. A single megaship can consume the same amount of energy as tens of thousands of homes while idling in port, placing a strain on local electrical grids and air quality. Historic port cities are suffering from the congestion of thousands of passengers disembarking all at once. In Venice, locals began taking to small boats, holding banners and physically blocking the paths of incoming ships. That resistance is spreading to other major global destinations, with residents demanding strict limits on daily arrivals. These growing protests threaten the operational future of the industry. The autonomous floating city works flawlessly at sea, but the external cost of maintaining that illusion is increasingly being paid by the fragile coastal communities it visits. At dusk, the cruise ship pulls away from the terminal. It drifts out of the harbor as a glowing monolith, echoing with music, light, and the warmth of human experience. But just across the water sits a very different kind of vessel. A gray naval warship rests low in the harbor. It is compressed, dense with armor, and entirely devoid of leisure space. The warship is built to confront the ocean directly. The mega cruise ship is built to ensure you never realize you're on it at all.